So, today we will be doing some physics. Because today we're looking into the application of the differentiation to the motion. And if we have x is the position of the object, what is velocity? Is the rate of change of the position.
That's a correlation.
How we find, for example, if we have that car accelerated from in 5 meters, it's a car moved, was at 5 meters, position 5 meters, moved to position 25 meters in the time 2 seconds. What is average speed? We will find 25 minus 5, change in the position divided by the time will be equal 10 meters per second. That will be average. But let's say when car starts from the traffic lights, it increases its speed, then move with maybe the constant speed, and it decelerates to stop on the next traffic light. So it changes all the time. So how we'll find instantaneous velocity? So velocity at this instance of time, derivative. So velocity is derivative of the position. Velocity is derivative of the position. Now, let's recall what is acceleration. You're all done in first semester physics in motion. What is acceleration?
The change in velocity.
The rate of change of the velocity. We've learned that acceleration equal final minus initial over time.
Yes.
But if what will be that average acceleration? The instantaneous acceleration will be derivative of the velocity over the time. That will be instantaneous acceleration at that instance of time. Now, what will be the relation between the acceleration and position? How we get from position to acceleration? We derive once, and we derive second time. So we have acceleration is a second derivative. That's how it's denoted. Second derivative.
So if you have a function,
That means
you find the quadratic and then you find the derivative of the quadratic, and then that's your acceleration.
so acceleration is the second derivative of the position.
Okay.
For this year, we just introduced the idea of the second derivative. Next year, you will learn some applications of the second derivative.
In methods or in?
In methods.
Yes.
In methods. In methods, you will learn some applications of the second derivative. You're not doing much in methods, but some, yes. Now, let's consider some examples. Let's consider some examples. Let's say we have particle moving in a straight line with the next particle moving in a straight line, that its position x changes over time, t cubed minus 11t squared plus 24t minus 3. So that is how position of the particle changing over the time. And of course, in all those equations, we always have time cannot be negative. So we're always looking into the time greater or equal 0, because time cannot be negative. Questions are
Is it 24 T or just 24?
24T. Yeah, thank you. Now, first question, what is initial position? Initial position is when t equals 0. What x equals? Negative 3. Now, t is time, yes. How position changes with the time. Now, find initial velocity. To find velocity, what we need to do? We need find derivative. Velocity is derivative of the position. So we need to derive it first.
Yes.
Derivative equal 3t squared minus 22t plus 24. And initial velocity is velocity when t equals 0. What is velocity? 24, that's minus 3 meters, 24 meters per second. What does it mean, negative 3 meters? It's not going, position negative 3.
I mean, it starts behind.
That it starts to the left of the origin. No, if it will have negative velocity, it means moving in the negative direction.
It stays at that velocity.
Now, we have found initial velocity. At what time particle stationary? What does it mean, what stationary?
You have to find x equals 0 at the turning point.
Huh?
When the velocity equals 0.
When velocity equals 0.
Yeah, so
Stationary means velocity equals 0. So velocity equals 0, we need to solve 3t squared minus 22t plus 24 equals 0. So we have 72, this is 8, 9, 16. How we factorize these? That will be, so that will be something like 3t, let's say plus
It's on
No,
3t
minus
minus
4.
4t plus
3t minus 4,
6.
3t minus 4 times t plus 6.
T minus 6.
Minus 6.
T minus 6, yeah. T minus 6 equals 0. So, what are the two times when velocity is 0?
4 over 3 and 6.
T equals 4 on 3 seconds, or t equals 6 seconds. So we have velocity equals 0, particle will be stationary at two different times, at 4/3 seconds and at 6 seconds. That was question at what times it's stationary. Now, what is the position of the particle when it was stationary? We substitute this into the, so we find x of 6 and use your calculators to calculate it. Use your calculators.
It's a waste of brain.
I have. It didn't have.
6 cubed 36 times 6 is 200. 216 minus 393. Okay, can't be bothered. Can someone use a calculator to do simple calculation?
Do you have a calculator?
Daniel's doing it.
Is no one else doing it?
This is doing it as well.
X negative 39. Now what will be x at 4/3 when time equal 4/3 if you substitute 4/3 into the x? Why only one student doing calculation?
Because we're lazy. Too lazy.
I'm doing with my head.
Now tell us results.
Daniel, it looks like you're using the paper.
Yeah, with my head.
I got 319 over 27.
Oh, Liz, it works.
319 over 27. Okay?
Wait.
So that is how we find
She got it wrong.
position.
Me? Did I?
No.
Yes, you did, Michaela.
Okay, so high.
You got different number?
No, he's literally playing Minecraft as we speak, Mr. B.
Mr.
Wow.
Mr. B. This is unbelievable. This is unbelievable.
That is low, Michaela.
This is a one-line, Michaela.
Okay,
You better watch your variation.
now, for how long particles velocity is negative? Now let's look when it is initially velocity is positive. When it becomes negative, at what time? As it was initially positive, and it is parabola. Clearly, it's parabola like this. So it becomes negative at 4/3, and becomes 0 at 4/3 and 6. So it's negative from between 6 minus 4/3. So 18 minus 14 over 3 seconds.
Yes, that makes sense.
That's for how long? What does it mean it's velocity negative? Where it's moving?
Backwards.
It's moving backwards. Find acceleration at any time.
Displacement divided by time or distance.
Velocity displacement. Now, how you find acceleration? What we do?
Derive the second
We
term.
find derivative of the velocity.
Are these questions gonna be on the staff?
This is straightforward.
Acceleration equals derivative of velocity equal 60 minus 22.
Wait, how did you get to intercept?
I find derivative of this.
Derivative of
The
derivative.
amount of time it's.
Yes, bro.
Acceleration is derivative of velocity. And last question, at what time acceleration is 0? At what time acceleration is 0?
22 over 6.
Which is 11 on 3.
That's like just over 3.3. It's like 3.6. Recurrent.
Okay, that's how you apply calculus to the motion in a straight line. Make sense? It's very straightforward. Okay, like, subscribe and donate to help fight terrorist countries and organizations, Russia, Iran, Hamas, Hezbollah, etc. Support Ukraine and Israel.
Yeah.